Hello everyone, and once again, welcome to channel. Today, we're embarking on a seriously fun journey. We're going to go from zero to hero with Jenkins CI/CD. We're taking the core foundational theories of continuous integration and continuous deployment, and we're translating them directly into a live, practical deployment on AWS. So if you want to understand how modern software actually gets from a developer's laptop to a live server without breaking absolutely everything in between, well, you're in exactly the right place.
Okay, let's dive into this. Here is our roadmap. First, we'll meet your automation butler. Second, core Jenkins components. Third, the CI/CD infrastructure. Fourth, installing Jenkins via Docker. And finally, building the pipeline.
Let's kick things off with Section 1, Meet Your Automation Butler. Before we dive headfirst into the terminal and the code, we really need to define what Jenkins actually is and, more importantly, the massive headaches it solves for us. If you've ever dealt with the absolute pain of manual, error-prone software deployments, where someone literally has to sit there copying files and running scripts at 2 a.m., you know there's gotta be a better way. Well, meet that better way. Jenkins is an open-source automation tool designed to do all that heavy lifting for you. Honestly, I want you to think of Jenkins as your tireless 24/7 automated butler. While you're asleep, this butler is wide awake, just waiting for developers to write code. And the second they do, Jenkins springs into action to automatically build, test, and serve up your software. The whole goal here is end-to-end automation. So why is Jenkins the industry standard? Well, first off, it's completely free and open source, so no massive licensing fees, which we all love. Second, it's got a huge, highly active community. But the real game changer? It's the extensive plugin ecosystem. Jenkins can integrate with almost anything. Git, Maven, Ansible, Slack, you name it, there is probably a plugin for it. It's also platform independent and highly scalable, meaning you can easily add multiple nodes to run builds across different machines without breaking a sweat.
Moving right along to Section 2, Core Jenkins Components.
Now that we know who our butler is, let's look under the hood and break down the specific components that make this automation engine actually tick. The fundamental unit of work in Jenkins is called a job or a project, and there are three main types you absolutely need to know. We start with freestyle jobs, which are kind of your simplest bread and butter. They're super flexible, and you configure them right through the UI for basic tasks like running tests or compiling code. Then we have pipeline jobs. Now these are a massive upgrade because they let you define your complex workflows as actual code using Groovy. Finally, multi-branch pipelines take the whole shebang a step further by automatically and dynamically detecting and creating pipelines for every single branch in your Git repo.
But how do these jobs actually know when to run? Well, that is exactly where triggers come in. They automate the execution based on specific events. You could use poll SEM, which just periodically checks your repository. But honestly, much more efficient are webhook triggers. These instantly fire off a job the very second a push or pull request happens on GitHub or GitLab. You can also use a scheduled trigger, like a traditional cron job, or cleverly chain sequential builds together using build after other projects. All right, let's get into Section 3, the CI/CD infrastructure. I absolutely love looking at this workflow because it perfectly illustrates what I like to call the hero's journey of our code. Let's trace it. First, a developer pushes code to GitHub. Jenkins instantly detects this and clones the code. Then, using a plugin like AWS Code Build, Jenkins builds the project and creates a zipped artifact. Jenkins handles that artifact through HTTP requests and file operations before securely uploading it into an Amazon S3 bucket. Finally, a deployment plugin, like AWS Code Deploy, takes over and pushes that application from the S3 bucket straight out to your live target environment. Just to make sure we totally grasp the exact flow before we hit the terminal, let's summarize that complex process into 4 super digestible steps. Step 1, the developer pushes code to GitHub. Step 2, Jenkins automatically catches it and builds the project. Step 3, Jenkins takes the resulting artifact and stores it safely in S3. And Step 4, Code Deploy handles the final deployment to the server. It's seamless, it's automated, and it's just beautiful. Which brings us to Section 4, installing Jenkins via Docker. Okay, it's time to get our hands dirty. Let's actually set this infrastructure up on an Amazon EC2 instance. We've launched an Amazon Linux 2023 EC2 instance here. The very first step to getting Jenkins running is preparing our environment by installing Docker. We just run the terminal command sudo yum install Docker. This package manager resolves all the dependencies and slaps the Docker engine right onto our cloud server. But of course, just installing Docker isn't enough. We actually have to turn the engine on. So we run sudo service docker start to boot it up, and then follow that with sudo service docker status. And right there, look at that bright green text saying active, running. That's exactly what we want to see. It means our container engine is running smoothly and is totally ready to host Jenkins. Now, this next part brilliantly illustrates the real power of Docker. Instead of some complex, messy, manual installation of Jenkins, we pull and run it with just one single command. We switch to root using sudo su and then run our Docker command. Notice how we map the port so Jenkins runs on port 8080? But absolutely crucial here is that -v flag. We're creating a directory called Jenkins volume and mapping it to var Jenkins home inside the container. This is a lifesaver. It ensures that even if our Docker container crashes or we need to restart it, all our valuable configuration data and pipelines persist safely on the EC2 server. So, our Jenkins container is spinning happily on port 8080 right now. But here's the catch. If we try to access it via our web browser, it's just going to time out. Why? Cloud security, of course. We have to go into our AWS management console, edit the inbound rules for our EC2 security group, and explicitly allow custom TCP traffic on port 8080 from anywhere. Once we save those rules, our Jenkins UI will finally be accessible over the internet. All right, the home stretch, Section 5, building the pipeline. With our Jenkins server successfully installed, running, and fully accessible, it's time to put our theory into practice. Let's build an actual CI/CD pipeline using a Python web application as our test subject. The crucial strategy here is breaking our pipeline down into logical stages. So, we start with a freestyle project named Python app build. We point it to our Git repository and set the trigger to use a GitHub hook. When a developer commits code, Jenkins executes a shell script. It runs Python 3 myvenv myenv to spin up an isolated Python virtual environment, activates it, and then runs pip install-r requirements.txt to install all our necessary dependencies. And here's the kicker. If this step fails, the whole process stops dead in its tracks, protecting our live server from bad code. But hey, we don't just deploy untested code, right? Once Python app build succeeds, it automatically triggers our next freestyle project, cleverly named Python app test. This is a perfect example of chaining jobs together. This test job sets up the environment again, but this time it executes Python 3-m unit test discover-s test. Basically, it runs through all our automated unit tests. Jenkins will only permit the process to move forward if the code passes every single test, no exceptions. Finally, assuming all tests pass, we reach the deployment stage with a job named Python app deploy. Jenkins executes a shell command over SSH to connect directly to our live server. It navigates into the application folder, runs a git pull origin master to grab that fresh, tested code, and installs any new requirements. Then it kills the old application processes using kill-all Junicorn and restarts the app using Junicorn on port 5000, which sits securely behind an nginx reverse proxy. And boom, the new feature is now live to the world, completely hands-free. Wow, we have covered some absolutely incredible ground today in this explainer. From understanding our Jenkins automation butler to configuring Docker on AWS, and finally chaining together a robust build, test, and deploy pipeline for a live application. So here's my question for you. What manual task are you going to automate first with all this new knowledge? Start small and let Jenkins do the heavy lifting for you. Thank you so much for joining me, and please don't forget to subscribe to the channel. See you next time.